So dear student, today we are going to learn some capsules. I hope this capsule will help you scoring some marks by answering to some short question. So before you start it, if you're new to this channel, hit the subscribe button, press the bell icon so that you get a notification as soon as I upload the videos here. So here we go. So here we will discuss about those capsules which are related to the first chapter. Matter in our surrounding. So the first thing related to the chapter is unit. Unit is a standard for measurement. So to measure any physical quantities, unit is required. The SI unit of mass is kg. SI unit of volume is meter cube. SI unit of temperature is Kelvin. So it goes as on. The unit itself is first topic. So we will discuss it separately on a later video. Now 0 degree Celsius is equal to how much Kelvin? So many of us know 0 degree Celsius is equal to how much Kelvin, and many of we don't know. So 0 degree Celsius is equal to 273.15 Kelvin, and for the convenience we take 0 degree Celsius equal to 273 Kelvin after the rounding off. Now we learn how to convert a temperature on Kelvin to degree Celsius and temperature on degree Celsius to Kelvin. So first, temperature from Kelvin to degree Celsius. So if you are given temperature on Kelvin and you have to convert to Celsius, all you have to do is you have to subtract 273 from the given temperature on Kelvin. For example, you are given temperature on Kelvin and it is 678, and degree Celsius it is not given, so you have to calculate the degree Celsius. By the rule, we know that degree Celsius equal to Kelvin minus 273. So putting the value of K, we get 405 degrees Celsius. So this was how we convert temperature given on Kelvin to degree Celsius. So next we have is temperature given on degree Celsius and you have to convert it to Kelvin. So in order to change temperature from degree Celsius to Kelvin, you have to add 273 to the given temperature on degree Celsius. For example, temperature given on degree Celsius is 20 and Kelvin is not given. So to convert the degree Celsius into Kelvin, we have to add 273 to the temperature given on degree Celsius. So by adding we get 293 Kelvin. So this was how we converted temperature given on degree Celsius to Kelvin. Next we have is ATM. This is not that ATM from where we can withdraw money. This is just the unit for measuring pressure exerted by the gas, and it hence called atmosphere. Before we learn the atmosphere, first we should know the atmospheric pressure. So atmospheric pressure is the pressure of air in atmosphere, and the atmospheric pressure at the sea level is considered to be 1 atmosphere, and it is taken as the normal atmospheric pressure. As we know, the unit of pressure is Pascal, and in case of the atmospheric pressure, 1 atm is equal to 1.01 into 10 raised to the power 5 Pascal. As we have studied earlier, that there are 3 states of matter: solid, liquid and gas. And now the scientists are talking about the 5 states of matter. Apart from the solid, liquid and gas, there are 2 more states of matter, and they are plasma and Bose-Einstein's condensate. So now have a look about these 2 states of matter. So first we will discuss about the plasma. This state of matter consists super energetic and super excited particles, and they exist in ionized form. Here arises a question that where does this particle exist? So we all have seen the fluorescent tube and neon sign bulb. So this plasma particle exists in it. The neon sign bulb, it contains the neon gas, and the fluorescent tube contains the helium gas. And when the current flow through it, the gas gets ionized and start glowing. And did you know even the sun and stars glow because of the presence of plasma in them? And finally, the 5th state of matter is Bose-Einstein condensate, and simply we called it BAC. It was named after the Indian physicists Satyendra Nath Bose and Albert Einstein. And for the discovery of the 5th state of matter, some scientists has received Nobel Prize in Physics. Well, this is formed by cooling gas of extreme low density, about 1 by thousands of the density of the normal air. So dear students, that's all for today. Next we'll be back with the next topic or next chapter. So see you soon.